Hey students, this video is on isotopes. To understand isotopes, you need to have a general understanding of atomic structure. All atoms have a nucleus at the center. The nucleus consists of positively charged particles called protons and neutral particles called neutrons. Much smaller negatively charged particles, called electrons, orbit around the nucleus. An element is defined by the number of protons it has. Changing the number of protons in an atom changes that atom's identity. Isotopes are essentially versions of an element that have different amounts of neutrons. Most elements have more than one stable isotope. Isotopes are named as the name of the element and then the number of protons and neutrons that isotope has. For example, oxygen has 3 naturally occurring isotopes: oxygen 16, oxygen 17, and oxygen 18. Since oxygen has 8 protons, its 3 isotopes have 8, 9, and 10 neutrons respectively. These isotopes have masses of 15.995 AMU, 16.999 AMU, and 17.999 AMU. On the periodic table, the mass listed for oxygen is 15.999 AMU. You'll notice that this is not the same as any of the masses of its isotopes, and it's not an exact average of each of those masses. This is because the average atomic mass of an element is a weighted average of the masses of each of its isotopes. This weighted average is calculated by multiplying the mass of each isotope by its percent abundance in nature. Percent abundances of different isotopes are found using mass spectrometry. A mass spectrometer takes a sample of an element and separates atoms by their mass. It then outputs a mass spectrum showing the percent abundance of each isotope. Let's go back to our oxygen example and try calculating its average atomic mass. The percent abundances are 99.757% for oxygen 16, 0.038% for oxygen 17, and 0.205% for oxygen 18. Take each isotope's mass and multiply it by its percentage. Then add everything together. You should get 15.999 AMU. Many isotopes are unstable and undergo radioactive decay when formed. An isotope is considered radioactive when its proton-to-neutron ratio is too high or too low. All of oxygen's naturally occurring isotopes are stable, but unstable isotopes can occur naturally, such as carbon-14. Radioactive decay is measured by half-life, which is the amount of time it takes for half of an isotope to decay. The half-life of carbon-14 is 5,700 years. The function for radioactive decay is shown here, where T is the time elapsed, N of T is the quantity of the substance remaining, N0 is the initial quantity of the substance, and T1/2 is the substance's half-life. This is a graph of the decay of carbon-14. A practical use of isotopes is carbon dating, a process used to determine how long ago organisms lived. Scientists figure out the amount of carbon-14 currently in a sample and compare it to the amount of carbon-14 that would naturally exist in that sample when it was part of a living organism. They can then calculate how many half-lives have passed and determine the age of the sample. That's pretty much everything you need to know about isotopes. Thanks for watching.